Our project title is Prediction of Heart Attack, Stroke and Recommendation System using IoT Network. Myself am Kavyanjali and my team members are Chandramouli, Krishna Ganesh and Bhuvaneshwari under the guidance of S. Suresh sir. Abstract. The IoT-based remote healthcare applications provide fast and preventative medical services to the patient at risk. It is very complex task to predict a heart disease. First, we will collect the physiological data from the patients remotely by using four sensors such as ECG, pressure, pulse, and glucose sensor. By using bidirectional gated recurrent unit and time series analysis. Introduction. A sophisticated system is required to conveniently and efficiently monitor the health of the heart. Internet of Things has today emerged as a crucial for the healthcare sector. Objective. Recommendation system for treatment and prevention, well-based user interface, preventative healthcare approach. Existing system. The existing Arduino-based system for monitoring the health of patients has several limitations, including inadequate connectivity due to the absence of integrated Wi-Fi or Bluetooth modules, as well as restricted processing and memory capabilities that hinder the management and storage of real-time data. Scalability poses a challenge as traditional configuration struggle to monitor multiple patients simultaneously. Proposed system. The deep cardio system has been proposed combines cutting-edge machine learning algorithms with IoT for quick and accurate diagnosis, treatment, and dietary recommendations of cardiovascular diseases. The recommendation component of the system uses the classified data to provide personalized nutrition and physical activity recommendations via mobile application. So this is the block diagram. In this we have sensors, Arduino board, prediction model, mobile app, and cloud server. Now architecture of bi-gated recurrent unit. So in this we have three layers: input layer, hidden layer, and output layer. Reset gate is input layer, update gate is hidden layer, and output layer is where to import the data from health reports. Leads and electrodes configurations. It is based on Einthoven's triangle. Contains three leads: lead 1, lead 2, lead 3. Lead 1 goes from shoulder to shoulder, and lead 2 goes from right arm to left leg, and lead 3 goes to left shoulder to right or left leg. IoT based ECG monitoring with AD8232 ECG sensor and ESP32. AD8232 is a neat little chip used to measure the electrical activity of the heart. It is used to help the diagnose various heart conditions. So this is the prediction table versus waveform. Advantages: remote monitoring, real-time data, improved disease management, enhanced patient safety.
Now I explain the hardware components of my kit. The main component of my project is ESP32 Wi-Fi module. So this is an ESP32 Wi-Fi module board and this is an ESP32 development board. So this is an 16x2 I2C LCD, that means liquid crystal display, that is used to display the values of heartbeat, glucose, pressure and temperature, etc. So this is an AD8232 heart rate monitor. It is also known as ECG electrocardiogram sensor module. It is designed to measure the electrical activity of the heart. So this is an HBT V2 DB9 proximity sensor. It is designed to measure the heartbeats by detecting changes in blood flow, typically through a finger. So this is the pressure sensor. It is used to detect the pressure. It is a temperature sensor. It is used to detect the temperature. This is the converter which converts AC power to DC power. This is a step-down transformer. It is an electrical device that lowers the voltage of an AC power supply. First, switch on the power supply. The first step we need to do in this is you have to connect this ESP32 to your mobile hotspot by using this username and password. So here you can see that ESP32 is connected to my mobile hotspot. The next step is you have to install the Arduino IoT Cloud Remote app. Now you have to open this app. So here you can see three dashboards: control, monitor and untitled. You have to choose the monitor. Here you can see the pulse, pressure, glucose and ECG waveform and the recommendation system. This is the glucose and heartbeat sensor. You have to connect this sensor to the HBT V2 DB9 proximity sensor board. Now you have to place your finger in this sensor and wait for the values. So here you can see the heartbeat value as 80 and also in the app. You can also see the glucose value as 107 and also in the app 107. So if your heartbeat value is below 110, then it is the normal condition. When your heartbeat value is above 110, then you can get the message like this: heartbeat abnormal, please contact doctor. So this is the blood pressure sensor. It is used to measure the blood pressure. So you have to connect this to the sensor. Now you have to press this sensor and wait for the values. So here you can see the pressure value as 87 and also in the app. So these are the normal values. When the person having the blood pressure above 120, then you get the message like this: BP abnormal, please contact doctor. So this is the ECG sensor. These are the leads: lead 1, lead 2, lead 3. You have to connect these 3 leads to this AD8232 monitor board. Now you have to place these 3 leads on your hand. Wait for the waveform. Here you can see the waveform. In this waveform, you can see the live values, 1 hour back values, 1 day back, 7 day back and 15-day back values with respect to time. So here you can see the time also.
These are the results. We can observe the normal conditions of pulse, pressure, glucose, and ECG waveform. Then we can see the abnormal conditions of pulse pressure. In pulse is above 110 and pressure is above 120 is abnormal conditions. Then we can see the messenger is BP and heartbeat is abnormal conditions. Please contact doctor. Conclusion. These